Great. So yes, so we're going to continue on the graphing functions and graphing quadratic functions and graphs. It is the handout that looks like this. Yeah, I'll pull it up. That's easy. And I'll be handing out a new homework today for us to work on. That's due a week from today. Okay, I wrote that. Oh, there we go. So as the handout starts off looking like this, I'll make it smaller. So that's the start of it. So pull out that one. These are the two we did last class. Okay, so I believe where we were was down on, we finished this part here of finding the values, and then we need to graph them. So our function is x squared plus 2x minus 2. There we go. All right. So it was f of x is equal to x squared. Was it plus 2x minus 2? Was that right? Or was it the other way around?
Plus 2x minus 2.
Okay, great. And so our points then that we found were, let's see, it goes -1, -3. Was that our vertex?
-1, -3.
Mm-hmm. And then 0, -2. And then I believe we must have gone with the 1, 0, 1, 1, 1. No, wait, I can't be right. 1, yeah. 1, 1.
2, 1, 1.
-1, -2. Right? And then -2, 1.
I think we want
Those are the 5 points we found last class.
we went with -2, 2,
-2,
-3, 1, and then 1, 1, and then 0, -2, and then -1, -3. That's what I have written down. Is that right down?
-2, -2, -2?
Yeah.
-2, -1, equals 1, or -3.
-3.
Yeah, there we go.
Yeah, -1, -3.
Okay.
So it's negative 3, 1.
Oh, negative 3, 1.
Mhm.
Oh,
Yeah,
that
you
makes
have
more
that one
sense.
too, negative 3, 1.
Yes, because we already have that twice. Thank you so much. I was like, wait, what? Negative 3, 1. There we go. Thank you, everybody. Perfect. All right, so let's see. I'm going to go ahead and draw in my lines here. It's not very thick. Let me try to get it a little bit thicker and straighter. That was a little too thick, but that's okay. No worries. All right, and then we can graph in our points. So let's see, we have negative 1, negative 3, 0, negative 2, 1, 1. Remember, you go first, you go to the elevator, left or right, and then you go up or down. So negative 3, I'll go left 3, and then up 1. Negative 2, back 2, and then down 2. So then we have our nice little graph here. And go something along these lines of some sort. Not quite accurate, but it's hard to really draw these. Go like that. All right, so we have our graph. Doesn't have to be perfect, just, you know, try to go through and hit those lines. Now, A, does a function have a maximum or minimum at the vertex? So which one's the vertex? I'm going to circle the vertex. Circle your vertex. Circle it. Means I need to see your pencil moving so that you actually circled it. Circle the vertex on, is this the vertex? If that's a vertex, circle it. That's a vertex. So there's 5 points. Circle the one that's the vertex. Okay, so the vertex is the very one, it's the one where it turns around. That's the vertex. Is that a minimum or a maximum? Is that the lowest point or the highest point?
Lowest.
Lowest point, so that's a minimum. What's the minimum, what's the value of the function at the vertex? So in other words, remember we're inputting an x, our output to the function, that's our y. So the y is the output, sort of what your answer. So when is our answer, our output, what is it at the vertex? Negative 3. It's the lowest point. Right, because it's the minimum. What is the minimum? Negative 3. Does that sort of make sense for folks?
Yeah.
That's the lowest it gets. B and C we're going to skip, so cross those two out. What's the domain of the function? Okay, so look back at the function. Domain f of x, x squared plus 2x minus 2. What are the two things we can never, ever, ever do? What's one thing we can never, ever, ever do? First thing you can never, ever, ever do?
Divide by 0.
Divide by 0. Right? You can never, ever, ever divide by 0. Good? Everybody on board? Are we dividing by something that has 0 in it? Do we have something over x or with something with x in it? No. Kelly's like, no. Is everyone on board with what I'm saying? In other words,
Except for where are we looking at? The original equation?
yes, the original equation. So we're looking right here.
Okay.
Oops.
So no.
We're looking right here. It doesn't have something with x being divided by. Okay, so then the second question is, what's the other thing we can never, ever, ever do?
Square or negative?
Square root of a negative.
Square root of a negative.
Do we have a square root here with x in it?
Yeah?
Square root.
Oh, square root. Square.
You can square a negative number. You can't square root a negative number.
Okay.
Is there a square root here with x in it?
No.
No. Does anyone remember what a square root looks like? I'm only getting one person answering me. Do I have a square root over here with x in it, like x minus 1 or something like that? No, I don't have a square root with x in it.
Oh, so even that you couldn't do because it's got a negative
Well,
underneath
this-
in the second number?
Okay, so this stuff over here is stuff I can't do. I can't have like 1 over x plus 2 or something like that. Okay, So if either one of these occur, I'm going to have limitations on what x can be. Is the red too not, is it blend too much? Should I do it in blue? Is that better? Or yellow? Pink? Is that easier to see?
I feel like pink is still pretty close to red.
Yeah.
Mm.
Yeah, but that was the issue, that it was blending.
That blends more, doesn't it? Or less?
Yellow.
Yellow?
Yeah, there you go.
There we go.
There we go.
That's a good color.
Keep that in my arsenal. Yeah. Okay. So you can never, ever, ever square root a negative number. So I have to make sure that x is such that that what's inside isn't negative. So that it limits what x can be. Does that make sense? For example, square root of if x was 0, then I'd have the square root of -1. We can't have that. That doesn't exist. So x can't be 0, for example. So does everyone understand what I'm saying? The top one? Here, I can never, ever, ever divide by 0. So x can't be -2. Because -2 plus 2 would make it 0. So whenever we're dividing by something with x in it, or we're squaring something with x in it, there's some restrictions on x. Here, we're not square rooting anything with x in it. We're not dividing by anything with x in it. So there are no restrictions on x whatsoever. Does everyone understand what I'm saying?
Negative infinity, positive.
Here,
Yeah.
there are restrictions.
Yeah.
Here, ours, no restrictions at all. X can be anything.
Mhm.
Is everybody seeing what I'm talking about? The only two issues where there's restrictions on x in terms of domains. In other words, the domain is going to be all real numbers, always, unless there's a situation where I'm dividing by x, or a situation or something with x in it, or a situation where I have a square root with x in it. So none of those going on, so my domain is going to be all real numbers. Negative infinity to positive infinity. Okay, so let's take, okay, and then last, the range. So the range, we gotta look at the graph for that part. What's the lowest it goes? -3. What's the highest it goes?
Infinity.
Infinity. So that's -3 to infinity. Can it equal -3?
Yes.
Yes, square bracket. Can it equal infinity? Can never equal infinity, so that's a rounded bracket. So you could also find the domain from the graph, right? You could say, oh look, it goes up and up, it goes up and to the left forever and up to the right forever, so it's negative infinity to positive infinity. But I do want everybody to be familiar with the concept that whenever we're talking about functions, it's always going to be, domain's going to be all real numbers, x can be anything, unless there's restrictions, unless it falls into one of these two restrictions. Right? Unless you're using a square root of something with x in it, or you're dividing by something with x in it. That will kind of help you the rest of the semester.
So we can never do one of those two items, but now you're telling us that if it has those items, there's restrictions.
There's a restriction
So
of some sort.
what is the restriction?
So here, x cannot be what?
Cannot be 0, I guess.
This can't be 0. So x can't be what?
Oh, -1.
-2, yeah. And over there, remember that's the one we did last unit? X has to be greater than or equal to 1 above.
Okay.
Because you'd have to make it, you keep it positive. Remember this one is the swoosh. Remember our swoosh?
Yeah.
Right, there's x is always going to be greater than or equal to something. Do you remember that? That's how that kind of works. Here it's going to be greater than or equal to 2 in this case. Or here it'd be greater than or equal to 5. So you can find it either graphically, like here it's greater than or equal to 1, or you can find it off of this fellow right here, square root of square root of x minus 1 means it has to be 1 or more. Okay, we'll go over those ones more. No worries. Let's go ahead and do the guided example 2. Some markers. Okay. So here, oh, okay, so this one is different. How is this one different than the previous one? The previous one, as a reminder,
What are you squaring?
so let me write out the previous one. Here's the previous one. Example 1. Was f of x is equal to x squared plus 2x minus 2. How is this different?
Here's
Okay, let's look at the first one. What's my a, b, and my c? What's my a?
x squared.
Negative.
It's the number in front of x squared. The coefficient is the number in front of a is the number in front of x squared.
So it's 1.
So, okay, I'm going to take 15 seconds with your neighbors. Find A, B, and C, and I'll randomly call on someone to give me those answers. So check with your neighbors. The red one up top. What's my A, B, and C?
Oh, the red one.
Talk to your neighbors. Don't say it out loud. Talk to your neighbors about it. Looks like I'm going to be asking David and Natalia because they're not talking to their neighbors. And pop across the hall if you want. Alex?
What is it?
What's A, B, and
She
C?
wants us to do the old one, right?
Find A, B, and C.
The red one.
The red one. The previous one.
The previous. Okay.
I'm just asking
We
to
got
find
it on
A, B, and
the
C.
front. We already did. Sorry. Yeah, well, I did that one too. You want to see that? Oh, I don't know, maybe, if you're squaring. No, because it's, that squaring doesn't have anything to do with it. You only have to do it up, it doesn't have to do with 1. Right?
Okay, so remember, A is the number in front of, it's ax squared plus bx plus c. A is the number in front of the x squared. B is the number in front of the x. And then c is just the regular number by itself. So what's my A in the first example, Alex?
X.
Because it's the number in front of the x squared.
Oh, 1, sorry.
A is 1. Eric, what's my B?
2.
Good. Ryan, what's my C?
-2.
Negative 2. Good? Now, our new example, what's my A, B, and C? I can't find them. Does that make sense? I'm having trouble finding my A, B, and C. Why? What's different about this, about the second one we're working on now?
Right?
Yeah, this one is what we call, this first one is what we call standard form. So this one here is standard form. Right? Ax squared plus bx plus c. This one here is what we call vertex form. Folks, what vertex form was? Vertex form was y equals a times x minus h squared plus k. So here, the standard form, I gave you A, B, and C. You had to find H and K. Does everyone know what H and K are? Who remembers what H and K is?
X and 1.
They are X and Y in a special situation. So they're a special H and X and Y. Alex?
They're the vertex?
Yeah, they're the vertex. H and K are my vertex, my X and Y are my vertex. So remember, H is, I'll go back and create a whole page. So H, vertex, H comma K. H is the X at the vertex. K is the Y at the vertex. And remember, how do I find H? And remember how to find H? It's negative B over 2A. And then my K is equal to whatever my function is with H inside. So you'll take whatever you got here, you'll throw it in there. Does that make sense? Throw it into the function for X, and that'll give you the Y. So our example, last time was Y equals X squared plus 2X minus 2. That was the one we just finished doing, right? So then our H was equal to negative, let's see, negative B over 2 times A, negative 1. And then we found that our K was equal to giant parentheses squared times plus 2 giant parentheses minus 2. So I just took this and I put it into here, right? I just wrote it down with parentheses in for the x's. And then, whatever we get here, we plug in to those values. So that equals negative 3. So then our vertex was negative 1 comma negative 3. I just took the original equation, wrote it down here, with big parentheses where the x's are, and then what I put in for the x, whatever I got for my h. My h goes in there.
And once you solve the whole thing, that's the Y.
Then that's the y, that's the k, yeah.
Yeah, the K, once you solve that,
Right, once I solve that, that's my
then
k.
it's the Y, yeah.
Yep,
Okay.
that's the y. Exactly. So now I'll put this, k equals f of h. Is that better? If I put it like that? Yeah, I'll put this one. I'll write f of x, so then it's more consistent, f of x. Right, so then we just put an h in for x. Oh, we don't have any, we didn't, no.
Oh,
not
good.
any yet. Okay. We're just finishing up the last one. All right, so this is vertex form, which means they have not given you the A and the B and the C. What are they giving you instead? Instead of giving you A, B, C, they are giving you A. They're giving you A and what else?
C.
H And what else? K. Does that make sense?
Those don't equal, like K is not C?
K is not C. No, it's not.
Yeah.
It's very definitely not. So here, instead, what's my A? A equals H equals K equals. All right, so everybody find from this function, with your neighbors, take a minute and find A, H, and K. Find them. Did you ever hand us last time?